Hi, my name is Josue Gallardo. I'm from Guanajuato University, and the topic that I was working is about to aluminum oxide. The title of my work is Photoluminescence properties of aluminum oxide embedded with carbon dots. Nowadays, the development of material with properties enhanced is important for the new technologies. The aluminum oxide is a material used in several applications over the years due to its properties like high stability, corrosion resistance, sound mechanical, and electrical properties like insulator with high band gap. The aluminum oxide has been used like matrix for being doped with different elements for photoluminescence properties, showing good results. In this work, aluminum oxide has been synthesized for combustion method embedded with carbon dots. The synthesis was carried out in a typical solution combustion method. Water and ethanol was used like solvents, aluminum nitride and citric acid like precursors, and finally ammonium hydroxide. The solution is heated until the gel formation. The gel is submitted to combustion at 600 degrees centigrade and calcined at 600, 700, and 800 degrees centigrade, where the samples were named ALO 300, ALO 700, and ALO 800. The material was characterized by X-ray diffraction and transmission electron microscopy for study its structural properties. Also, UV photoluminescence and X-ray photoelectron spectroscopies for its optical properties and thermoluminescence measurements. The figure 1H shows the XRD pattern. The sample ALO 600 and ALO 700 in general show an amorphous structure due to the high carbon dot contents. In change, ALO 800 shows high crystallinity caused by the low carbon dot content and high calcinate temperature. By the other hand, the temp image microscope of ALO 700 shows an average particle size of 47 nanometers, and the HR temp shows some crystalline planes, but in general an amorphous properties, which is expected from the HRD pattern. Also, in red circles on temp image can be seen a smaller black point deposit over other particles with well-named carbon dots. In the UV spectrum, it's appreciated that the three samples shows the main peak absorbance of the aluminum oxide in 270 and close to 400 nanometers, but different absorbance up to 400 nanometers, which is due to high presence of carbon in the samples, and it's appreciated on the visual way in the coloration change from the brown in L600 to white in L800. Also was calculating the optical bandgap obtaining values of 1.6, 2.4, and 3.5 electron volts, where the presence of carbon dots cause a bandgap reduction. For the PL spectra, the three samples has a wide emission centered on 470 nanometers due to carbon dots where ALO 600 present an out absorption. In addition, ALO 800 shows an emission peak close to 700 nanometers caused by chrome contamination. In the XPS, were the carbon, nitrogen, aluminum, and oxygen, which confirm the presence of carbon with some peaks from different chemical molecules like functional groups of the carbon dots. Finally, for the TL measurement shows a curve from 50 to 300 grade centigrade, centered at 200 grade centigrade for LO 700 caused by a deeper time in comparison to LO 600 and LO 800, which could be caused by the embedded carbon dots. Like conclusion, it's possible to synthesize aluminum oxide embedded with carbon dots by combustion method with an average size of 47 nanometers for LO 700. The carbon dots modifies the band gap of the aluminum oxide, where was obtained a value of 1.6, 2.3, and 3.5 electron volts for LO 600, LO 700, and LO 800 correspondingly. The three samples have an emission due to of the carbon dot centered on 470 nanometers. In addition, LO800 has a red emission due to chrome present centered on 700 nanometers. Finally, by HPS spectral was confined the presence of some carbon functional groups of the carbon dots. Thank you so much for your attention.